Okay, the fundamental theorem of algebra basically is this. Again, we've talked about it for everything, so we're just officially putting something to it here. If the highest power of an equation is x to the n power. And again, this is something we've talked about a bunch, but this, I don't know why they wait until chapter 5 to talk about this one, but this is just kind of where we've done this. So we've mentioned it a bunch of different times. But if the highest power of an equation is x to the n power, you will have n answers. And you may be saying, well, we've talked about that a bunch already, because we've talked about it, I know, at least for 2 or 3 weeks, probably even longer than that. It is, but this is the first time they officially talk about it, and that's what the fundamental theorem of algebra is, says that if you have x to the 5th as your highest power, then you got to have 5 answers. You know, we've done it with quadratics and everything else on this one. And some of the questions that you'll get in section 6 on this one hopefully will be really, really easy, because they're going to ask you basically a question like this. How many solutions does the equation have? And then we'll give you like 2 examples here. So maybe something like that. All right, and again, it just says, tell me what's the highest power. It's 7, so there's 7 answers we're going to have. That's it. That's all you got to do. And again, we've been doing that for, I'd say, at least over a month, where we've been talking about different things with this one. So it's not anything new. It's just reminding you this is where it would be here. And it doesn't have to be the very first term. It can be any term along the way. It could be a problem like that. This would be standard form where it's written in descending order. B is what problem where it's just written. There's no order to it. We just kind of do whatever for this one. Find your highest power. It's x to the 4th. So how many answers we're going to have? 4 answers. There we go. Okay, so that's some of the questions that you'll kind of see in section 6, where, again, very simple, very straightforward. Just how many answers does this thing have? And you don't have to find them. In this case, if they just ask how many there are, that's all you have to do. All right, now the later part of section 6, this is where they're going to come back and they're going to give an expression, and they're just going to tell you to solve it. They may put something in there that your answers might be imaginary. They probably will have something about writing your answers in complex form, something about using variable I. Basically, they may give you hints. All right, well, on these answers, they might possibly be imaginary. They may not be, but they also might be. So just kind of, be on your toes, because either one of those could kind of be there. All right, so we're going to do 2 or 3 just to make sure everybody's still comfortable with doing synthetic division and checking and seeing what all you can do for these. All right, so let's go with y equals x to the 3rd minus 5x squared plus 16x minus 80. All right, and the very first thing I still want you to do is that if you're solving any of these problems that you have to do, again, this is one of those where they kind of just open the doors up. Sorry, any way you can get there, you can do this. The very first thing that you always want to do is see if you can factor. And for a problem like this, if you look at the part up here, you've got 4 terms. So let's see if grouping would work. We'll put a question mark. Maybe it will, maybe it won't, because it's about 50-50. Some of the four-term expressions you got, you can do factor by grouping. Some of them you're not able to. Okay, so if we group the first two together and the last two together, let's see what we get here. All right, so we've got x to the third minus 5x squared and plus. Again, always take this sign inside with it here just in case that's a negative so it doesn't lose anything. So we've got 16x minus 80. All right, and from there, we've got an x squared we've got in common here. So we'll take out 2x's here, that'll leave us with 1. You take out the 2x's here, that's going to leave you with the minus 5. All right, and if that's the case, we know that this one would have to be x minus 5 if this thing is going to work. Because if this is not x minus 5, then these two things are off. So basically, we're taking out the 16 because for this thing to be x minus 5 on the inside, we've got to take out the 16. If you check 80 divided by 16, that does wind up being 5. So then we've got something that works here. Okay, and then we'll bring our two greatest common factors together. So we've got x squared plus 16, and then we're just going to put the x minus 5 back behind it there. All right, and hopefully this is kind of ringing a bell at this point, because now we're back to what we were doing back in 5.5. We've got this thing factored down to here. We can set each parentheses equal to 0. This one, we'll just add 5 to both sides, and we've got our first answer there. We set this parentheses equal to 0. We'll subtract the 16 over. So x squared is equal to negative 16. And remember, because it is x squared, we've got to square root both sides. All right, I'm running out of room here, so I'll put those answers over at the bottom over here. If you square root 16, that would be 4. But again, because it's negative 16 instead of it being just 4, you got to put the I on there for the imaginary part. And back here in the beginning, again, it was x to the third. So we're looking for 3 answers. There's one. The positive would be another answer. The negative would be the third answer that we're looking for there. So there's the 3 answers we're looking for off this equation. Okay, so there's one option of some things that you can do. And again, my first thing is always try factor by grouping if you've got 4 terms. If it's more than 4 terms, and we'll give you the next one here, that's coming up to kind of show you, there's really no other, you don't really have an option. This one, we tried factor by grouping, it worked. We'll come back later and show you one that doesn't. But here's one that you don't really have an option on this one because there's no other way that it's set up, so you don't really, it's the only way that you can do this one. So let's go with x to the 4th plus 4x to the 3rd plus 7x squared plus 16x plus 12 equals 0. All right, big difference on this one is it's got 5 terms. We don't have any factoring rules that you can do for 5 terms. Once we get to 4 terms, we're out. So we don't have anything on this one. So for this one, this is where if we don't have anything to do, this is where you have to do P over Q. And again, if we're doing P over Q, it's the factors of 12 over the factors of 1. And the good news is if it's over 1, then we really just have to worry about the factors of 12, because that would be 1 times 12. That would be 2 times 6. And then this would be 3 times 4. Again, the only factors of 1 is plus or minus 1, but if we're dividing everything by 1, then it doesn't really worry about it. So all the possible factors then would basically be the 1, 2, 3, 4, 6, and 12. All right, now here's the one. Now the last thing we did on Wednesday, one of the last things we did, we talked about Descartes' rule of signs. Here's the one time where I want that to kind of be ringing in your head, because if you look at this problem that's here, what's something y'all notice about all these problems here? What do you notice about all these terms? What do they all have in common? That they are all positive? Okay, get back, no, because we got a positive here, positive here, positive here, positive here, positive here. So we go back to this one back here, positive, negative, positive. So it was mixed up. If you ever see it so that they're all the same signs, listen to me do this. Let's just say that they're all the same signs. If the terms that you get in the beginning are all the same signs, that means that positive answers won't work. Because there's no way you can plug in any, because all these answers are positive. If you keep adding, if you start with 1, every single one of these numbers, you're going to keep adding something to it. So that when we're doing this one, we only have to worry about checking the negative answers. So we only need to check the negative. So we only need to check the negative. So we only need to worry about -1, -2, -3, -4, -6, and then -12. Okay, now that's the one time that the Descartes rule of signs to me really jumps out and helps you out from what we're doing back on Wednesday. That if all these terms are the same sign, which most of the time it's going to be all positive, that means you don't have to worry about checking the positive solutions. You only worry about checking the negatives. So now we're going to go back through and start guessing and checking. So we're going to start with 1, +4, +7, +16, and +12. Okay, and a lot of times people just like to guess and check. I'm one of those, I'm saying, all right, well, probably the best thing to do when you do these is start with -1 and see what happens at -1. If that one works, then we've got something going. If -1 doesn't work, then we'll go to -2, then we'll go to -3, then we'll go to -4. Just start at the smallest number here and then work your way up and go from there. All right, and this will be a good review. If you forgot how to do synthetic division, here's one more review to kind of make sure we got it. We brought down just the terms up here. You bring down the first number below the division bar, and then we start multiplying. -1 times 1 is -1. 4 minus 1 is +3. -1 times 3 is -3. 7 minus 3 is 4. -1 times 4 is -4. 16 minus 4 is 12. And -1 times 12 is -12. So that makes that 0. And that's what we want. That last number is 0. That's a yes. That's what we're looking for. So x equals -1. That's our first solution that we're looking for. And the big thing on this problem is because we started off, and I'll bring it back down real quick. We started off with x to the 4th. So we're looking for 4 solutions. We've got one solution now, and this one's good. So we've got a solution here. Now you can keep going. You could take these same numbers you've got here and bring down the 1, the 3, the 4, and the 12, and then you can check -2. And if that worked, then we can check -3. We can kind of go through that list. But here's the other thing we want you to kind of notice. Try this one first. Once you've done one number, and now you're down to 4 terms because this one's gone, you're down to 4 terms. Now you can try factor by grouping again, because you're going to have, if you rewrite this and where we're going to be, this would have been x to the third plus 3x squared plus 4x plus 12. So since that's 4 terms, we want to try factor by grouping. Because here's kind of the dirty little secret for these. More than likely, once you get one number that will check, this thing will almost always factor. There'll be a few times where it won't, but almost every single time this thing is going to factor. And again, if it doesn't, then you just go back and do synthetic division. But if you do that, more than likely you could get that same answer by factoring. So if we group the first 2 together and the last 2 together, the good news is that these are all positive, so it's a little bit easier. It's x to the third plus 3x squared plus 4x plus 12. All right, x to the third and x to the second, you can take out an x squared. Leave you an x plus 3. 4x and 12, we can take out a 4. All right, we've got what we wanted. Now we've got the same thing here, so we'll bring the x squared plus 4 together, and we'll do the x plus 3. And then that part of it looks a lot like what we're doing on the last problem. You're going to set x plus 3 equal to 0, and then we're also going to do x squared plus 4 equal to 0. Well, this one, we get the answer right off the bat. We'll subtract 3. There's our second answer, because there was our first answer. Now we got our second answer. This one, again, is a lot like the other problem. We'll subtract 4. And because it's x squared, we're going to square root it. So when you square root negative 4, it's going to make it plus or minus 2, but because the negative on the inside, that's going to make it a 9. All right, so if you need all 4 answers, there's all 4 answers. Now, somebody may be saying, well, what about the positive 2i? I thought you said we were going to use any positive solutions. Remember, if it's imaginary, since it's imaginary, it's like a made-up answer. It doesn't really count for the positives and negatives. That's just for the whole number of options we're checking. So if it's an imaginary number, because it's an imaginary number, the plus or minus doesn't really matter because it's imaginary. It's a made-up number, if you want to kind of think about it that way. All right, and then the last problem I want to show you. That you actually have to write down. There's one more after that I'm going to show you, but you don't have to write it down. Last problem that we'll show you here, just to make sure everybody's good with it, because again, sometimes people kind of forget because they get kind of locked in on what they're doing and forget about a few things here. Let's go with x to the 4th minus 3x squared minus 4 equals 0. Okay, so first thing is, again, it's x to the 4th. So we know we're looking for 4 solutions. And some people may go, well, if it's x to the 4th, we don't really have a trick thing for x to the 4th, so we'll do that. I'm going to show you something at the end where you actually could do this. Here's the big thing we're going to do for this one. We're going to do the p over q, which again really is the factors of 4 over the factors of 1. The good news is that it's over 1, so there's only a couple options, well, 3 options. Plus or minus 1, plus or minus 2, plus or minus 4, because if you put this over 1, it doesn't really do anything, so those are only options that's really possible is the 1, 2, and 4. Okay, so 4 solutions, and we've only got 6 numbers to check because you got positive or negative 1, positive or negative 2, positive or negative 4, which means we've got a really good chance of getting something that's going to work here. All right, when you get ready to do synthetic division, here's one thing that you have to do though first. I want to show you this one just because most people are kind of going to go over this route. If you don't make this one little change, you're going to mess things up. You've got x to the fourth. Because remember, whether you do synthetic division or long division, you've got to have every power. You've got x to the fourth. We skipped over x to the third. So you got to go back and put a 0x to the third in there. We've got minus 3x squared. We skipped over x to the first. And then we had the minus 4. Okay. And that's kind of a big one because a lot of times people get locked in on doing the division and they forget to go back and see that they've got all the terms there. All right. If you miss a term, you've got to go back and put a 0 in there for a placeholder. Now you can actually go back and do your synthetic division. So we need the 1 here. If you don't put the plus, that's fine because 0 is not really positive or negative, so it doesn't really matter. -3, 0, and then -4. All right, and now we're guessing and checking. And again, I would say start with the numbers here. Let's start with a +1, or you can start with -1. Doesn't matter. Just start with the ones, and then we'll check it and go from there. All right, 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 0 minus 2 is -2. And then 1 times -2 is -2. That's going to get us -6. That's not going to work. Okay, so +1 didn't work. All right, I'm going to save us just a little bit of time on this one. If we check -1, it's also not going to work. So we're going to check the 2's and see if those 2's are going to work. All right, so let's check +2. Okay, so same numbers here again. Start with pulling it down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. -3 plus 4, again, you can go reverse over. You can go 4 minus 3. That's going to be 1. 2 times 1 is 2. 0 plus 2 is 2. And then 2 times 2 is 4. That does get us the 0, so that checks off. That is what we wanted. So the first solution we've got here would be this one, that x equals 2. All right, and again, there's a really good chance that as you're going through these problems, once you get one answer, this thing probably will factor. So this would start off with x to the fourth up here. This is always going to start off 1 less power. This is going to be x to the third. 2x squared plus 1x plus 2. Again, our question mark is, will this thing factor? If it doesn't factor, then we'll take this thing and then go back and do synthetic division with it. And we can keep checking from there. But hopefully in this case, it's going to factor. They're all positive, which does make it a little bit easier. So we got x to the third plus 2x squared plus the 1x plus the 2. All right, x to the third, x to the second, we can take out an x squared. And then leave you with an x plus 2. All right, again, this is what we talked about the other day, but it never hurts to kind of remind it that if you get here, you've already got x plus 2. This one's already x plus 2. If this is already the same as what this one is, then basically you just go back and take out a 1. That would be your greatest common factor. Okay, so then first parentheses will be x squared plus 1, pulling these two numbers down. Second parentheses will be the x plus 2. All right, one easy answer. With the x plus 2, we'll set that equal to 0. Well, that's very, very quick, very easy answer. That's x equals -2. And hopefully everybody's kind of noticing now that these start to look a lot of this. It's a lot of the same things, just repeating different times. You're going to move that -1 over when you subtract it from both sides. And then you're going to square root both sides. And you keep saying, well, that seems to be happening a lot. It does, because of how these problems are set up. A lot of times it's going to be a lot of those same steps when you go through these. And when we square root -1, that would be 1i. But if it's 1i, then you can just rewrite that as I. So we had 2 from up here. We had -2 here. We have plus or minus 1i there. So if we write all these answers together, we had 2, -2, and then plus or minus I. And I guess technically you could have put a plus or minus 2 on this one, but sometimes they'll let you do that and sometimes they don't. Okay, so that's just want to kind of show you that one because, again, if you've got terms that are skipped, you can do that. Now, let me kind of also show you a couple little things here, and then we'll be done with this one. A couple of little things that you can do along the way. That this was kind of like a trick question on this part of it because you actually could do this problem 2 different ways. You could have actually done this same problem, and you don't have to write this down, but let me just show you. You also could have done this one by factoring. That if you kind of pretended like this had been, x squared minus 3x minus 4, this one you could have factored off as like x minus 4 and x plus 1. The only difference between these two, and if nobody ever told you this one, is that if it's 3 terms, as long as these are even like this one is, that if this power is less than half this one, you basically can go ahead and break this thing off and have it as x squared minus 4 and x squared plus 1. So it's the same thing that's here. You just have to bump up the powers. And then if you set both of those equal to 0, well, then we're right back in the same situation that we were. This would be x squared equals 4. Square root it, and we get the plus or minus 2. This one, you would subtract the 1, you would square root it, and then you get the plus or minus 1i. Now, a lot of times people don't see that because the x to the 4 throws them off, but that's one option that you could have done there to kind of get through those answers. You don't have to do it that way, but it's just a possibility of what you could do to kind of get through those to make it out to be what it wants to be. Okay, so again, you could do it that way, or you can go back and put the zeros in place and do synthetic division with it. It's really your choice which way you want to go with it. Sometimes people don't see that. But hopefully also you remember that if you go back and put the zeros in there, that'll kind of get you through that one too. That's your call on which way you want to go with that one. Last thing, again, you don't have to write this one down, but let me just show you this one real quick. And this will be the last thing for today. Here's one, again, don't write this down, just kind of watch it. Here's one where we have 4 terms, and factor by grouping did not work. And if factor by grouping doesn't work, then now you're just going back to find the P over Q, and then you're going to set up synthetic division and go from there and check until you can see you find a number that's going to work. Now, and the good thing on this one is that after you found this answer on the first one, it actually has a problem that you could factor because now you've got x squared minus 3x minus 4. You could factor that one and then get your answers and go from there. So don't think that everything that you're going to do, will always be something weird. This is one where this come out to be weird. It came out to be just regular numbers to kind of get what you need there. So sometimes factoring by grouping will work. This would be an option where, depending on the signs and numbers there, factoring by grouping didn't work for this problem.